So hello everyone, today we'll discuss the carpooling or sharing system in this video. So the outline of this entire video is today we'll discuss about the introduction or the need or importance of the application. Then after that we'll just go through the related work, then the gaps and problem statement, like what the problem is this basically, and what's the objective of us, and what's the existing model for this problem, and what are the proposed model, like what we are going to do for this problem, and at last we'll just do the conclusion and references. So basically we'll start with the introduction. So the question arises, what is carpooling and where this concept came from? So basically carpooling is the sharing of car journeys so that more than one person travels in a car and prevents the need for other to have to drive to location themselves. By having more people using one vehicle, carpooling reduces each person travel costs such as fuel, cost, toll, and the stress of driving also. This concept came, like, now the question is from where this concept came from. The question is, carpooling first took place in the United States during World War II. The fashionability of the internet and the smartphones has greatly helped carpooling to expand, enabling people to offer and find lifts that are easy to use and dependable. In the 1990s, it was popular among the council scholars with, like, who's having the limited parking spaces. So the basic importance of our application. Our project idea is to peer-to-peer carpooling system. Currently, most carpooling systems are in the control of only one agency, just like Uber, Ola, etc. We are creating a small contract that will connect the rider and driver directly without the intervention of any third party like Uber or Ola, because these third party apps just take the data of the driver and they take the data of the user also, and which can lead to a major privacy issues. Just like it is written in here, agencies like Uber and Ola have all the data of drivers as well as of the riders, as this can lead to a major privacy issues. If somehow ride sharing and car hire was moved to blockchain, then we can build a much more reliable carpooling system, so which will be much effective, and which we can basically say that will work on a privacy system.
Okay, so now quickly I'll just be walking through three papers that are related to the project that we are working on. So the first one is basically design and analysis of a secure decentralized car sharing system using blockchain. So this was authored by, as you can see, Johan Park, Kilhon Park, and Johan Park. So this paper, uses the method of blockchain, of course, uh, you, stressing on the decentralized model concept. So of course, the main features would include decentralization, data integrity, authentication. So what is this paper all about? So this paper actually talks about how can we design and analyze, a secure decentralized car sharing system, which is already being done, but this research, the author is trying to do that using blockchain. So as I already mentioned, the few of the highlights or the main features include decentralization. So of course, the system is designed to eliminate any single point of failure, like fault tolerant. It's trying to be a fault tolerant system, just because of the decentralization concept, because it is going to be decentralized on the blockchain network. The second highlighted feature is data integrity. So of course, data is everywhere now, and so the integrity of data is very important. So we should be able to not tamper that data. So we can say that the data is going to be tamper resistant and reliable rather. So that is another feature that is being highlighted in this paper. And then of course security authentication, so anonymously it is authenticated, so each of the participants don't know who are the other participants present on that blockchain. It is because of the authentication capabilities of blockchain here. uh, these were some features. We do have certain challenges. When we went through the paper, we realized that there were certain challenges highlighted by the author. First and foremost was scalability. They were not able to they were thinking, how can this come on a large scale? I mean, how can we make this on a large scale or grow it as a large scale, or later how can we make this as a business model? So these were things that were not really highlighted well in the paper, and they mentioned it as a challenge. And of course user adoption, it's correlated. We'll have to convince users to trust and transition to this new decentralized system, because we are used to the conventional system of, let's say, analyzing using, let's say, databases and excels and other simple database analyzing tools. So now when we are trying to move that all to blockchain, some people are not going to you know be convinced, or they'll not find that same trust with blockchain. So user adoption is going to be a major challenge, and of course cost efficiency. So whenever it's a new technology, so there's going to be higher costs. Although we are trying to use the research author, as as the author states, they want to balance the benefits of security with decentralization, with computational and communication costs. So these two things are very hard to balance, so cost efficiency is going to be a major challenge. So this was one of the papers. It was a very interesting one to go through. Okay, moving on to the second paper. So this is a car sharing platform that is entirely based on blockchain. It is harnessing every aspect, or rather the security aspect. So here again, this paper tries to bring in a car sharing platform that uses Ethereum smart contracts and Solidity programming language. So the thing is, so the Ethereum smart contracts are based on certain NFT standards. So like they are based on ERC 721 and ERC 20, as it's mentioned. So that's like a standard. So standard in the sense, like, now let's say if we talk about the programming paradigm, we call C language as a standard, right? So the same way over here, that NFT standard is being set up. So they're trying to use that particular standard to implement this car sharing platform. So as we can see over here, the certain main features, once again, decentralization. It's a common feature, of course. That is the only difference is it's going to work on that particular NFT standard. As we can see, ERC 721 and ERC 20. So these would be representing the car assets, and so basically NFT is non-fungible token. So that is why it's saying to unlock tokens and reward users, incentivizing the participation. So of course, if something is free, no one values it. So when we start rewarding someone, even the user in this scenario, then they will be incentivized to try to use the application more. So of course that is good for the environment indirectly. So that is the main highlight. So that is where they're trying to use decentralization. And of course we have IPFS integration. So IPFS is basically just interplanetary file system. So this is like how we have this NFTs, right? So now so many NFTs are there, so we need a marketplace where all these things are there. So IPFS is a concept related to that. The expansion, of course, is interplanetary file system. It's just to manage everything, to organize the file. You could call it the file explorer of their application. They're trying to integrate the feature of IPFS for that. So this way, the cost of Ethereum transactions will reduce while maintaining efficient image retrieval. So there will be certain optimized algorithms to not compromise on the quality, but at the same time make it cost effective. So these are the two main features. And of course, we have certain challenges that the author of this paper has highlighted. That is mainly security and stability. So as we can see, it's a very heavy application that's coming up, right? So we have IPFS integration. We're trying to use a standardized token. So so many things when you put in there, there's a scope for bugs is huge. So obviously, how stable will this be? And the other aspect is, since there are so many things, trying to add enough layers of security for everything will be tough, because so many protocols are being implemented, so many standards, so many token concepts are being implemented in this. So obviously adding a security layer and everything will make the application huge. So we might try to conceal it with a umbrella kind of security. So this makes it vulnerable for attacks, any potential attacks that might be critical. I mean, it might attack some critical services, making it an unreliable product. So this is one of the main challenges. And apart from this, integrating the whole idea in with blockchain and smart contracts, and then the whole car sharing industry is going to be a big challenge, because how do we integrate both of these things also while maintaining the standards that blockchain has given us, or the opportunities that lie there. So balancing all that and then making it cost efficient, so all this poses as a big challenge. But once we crack that, then it's a very good application. So that is what we saw in this paper. So moving on to the next paper. Yeah, that is the third paper. It is an efficient, secure vehicular networking architecture. So just how we have IoT, Internet of Things, we can have Internet of Vehicles. So that is what the author Kamal Kumar and Sachin Sharma of this paper are trying to highlight here. So here they are trying to, talk about the security and sharing aspect. So that is what this paper is talking about. So if I go one by one, the main features, of course, security enhancement. So since we are deploying blockchain into this, it is going to increase the trust, reliability, and the privacy and security concerns are going to be addressed. It is not clearly mentioned how they're going to do it, but of course the standard algorithms and models, that is how they will be doing it. That is what we understood. And moving on to the challenges quickly, we can see that even though we saw the main feature would be privacy and security, now since everything is being fed into the system, that becomes a challenge as well. Because just imagine somehow, if the blockchain system fails, it cannot fail, it has never failed so far. But if something like that happens, just because of the application interface, maybe it is not on the blockchain entirely, something is still on the physical database. Because at the end of the day, it's carpooling, it's a physical thing that is happening. So privacy and security becomes a concern. Would how will paper addresses happen through blockchain integration, or how will vehicle network communication be preserved without a compromise on security? So these are certain challenges that were actually highlighted in this paper. And of course resource allocation. Now when we have so much data, we're trying to secure each and every data. So imagine a simple DES or an AES, encryption method has so many processes, so many keys to store, so many decryption methodologies to store. Now when we're talking about blockchain, they are highly complicated, not complicated, like more advanced, or rather they'll have a lot of substitution boxes and other technical terms to handle and store. So resource allocation itself, or the processing and computing power itself, might be high, which indirectly is going to make it highly costly, you could say. So increasing the cost and high computation power, then how do we balance that with the quality and the service that this application is trying to offer? So when we go through all this, that is what this author is trying to say. So he's just trying to tell, this is one issue, this is a security issue. So everything put together, we understood that we need to try to keep all these things in mind while making our paper. So that is it about the papers. Moving on. Yeah, so quickly, if I were to talk about the last three papers that I just explained, uh, let's call it a summary of the gaps that we found in the previous three papers. So obviously, we noticed a lot of challenges. One of the main challenge, of course, was the scalability issue. So how do we make this on a large scale? I mean, yes, blockchain is technically, you could make it look infinite, but then comes the issue of computation power, which is indirectly the cost. So how do we implement an effective business model to make it highly scalable, especially in a system like carpooling? So this is one thing that we are thinking about, and let's try to minimize this issue when we work on our project. And of course user adoption and trust issues. Now we need to, we know the target audience, but now how do we convince them? I mean, they need to believe in our product, or believe in our project, believe in the system. So that is another major concern. Apart from this, the technical network issues or network communication vulnerabilities like privacy preservation, regulatory compliance, and energy efficiency. So these things, how do we overcome that? So we'll have to try to implement more efficient algorithms, trying to improvise the algorithms that are already present, and trying to operate all the advanced systems that we want to, or we are trying to propose on existing infrastructure. So that would save high cost, and it's obviously going to directly affect the environment in a good way if you're able to harness the existing infrastructure rather than implementing new ones. And then how do we, so these were few challenges that we observed, right? So another thing is, now if let's say the user is happy in using the product, so I told the word happy. Now how do we make them happy? So one way is to incentivize it. So like trying to give some rewards, or trying to encourage them. Like if you take an example of any mobile game, the reason people get addicted to it is because they're getting that, yay, congratulations, you won. So something like that. So these kind of small incentivizing mechanisms in the real world, like carpooling, so that many people use carpooling, it's going to revolutionize the transport industry then. So we'll have to think about a good incentivizing mechanism, that is currently being considered let's say a disadvantage or a challenge, because we're not able to find something that is able to use the retain the users for a long time. Apart from this, obviously complying with the government, the governance model, how do we uh, long-term viability and sustainability, because it shouldn't be like, see, carpooling itself was introduced so that it is better for the environment, less pollution and etc. We shouldn't be polluting more, we shouldn't be harming the environment more just because we're using more computers to achieve the same. So all these things were certain gaps in the research papers that I just presented. So that's pretty much it. Moving on.
Now I will be explaining problem statement. Currently, traditional car sharing systems are centralized and there are hundreds and thousands of vehicles in India that travel from one city to another, passing through neighborhoods to metropolitan areas daily. However, the number of taxis in major cities falling significantly short of the demand, leaving many people waiting for the taxi for by roadside. Additionally speaking, the increasing number of cars is uh, causing adverse environmental consequences such as car exhaust emission, a wide variety of gases, hazardous material which can lead to global warming and harm human health. Furthermore, speaking, cars and car drivers who are not covered by any tax healing services facing dramatically increasing unemployed rates. Moreover, due to attractive prices of offered by Ola and Uber, local drivers have lost a sustainable portion of their customer base. Lastly, ride services networks also encounter issues related to privacy, including security of financial details, privacy of personal information, and location as well as the data. Why we are utilizing blockchain innovation to fathom the security related issues. So next slide. Now speaking about the objectives, implementing person-to-person carpooling system using blockchain technology can offer various benefits. Here are some key objectives. Enhance security. Now talking about enhanced security, utilizing blockchains secures and immutable ledger to protect user data, transaction, and identities, ensuring trust within the platform. Transparent transactions. Implementing transparent and tamper-proof uh, transaction records allows user to track payments and ride his, ride history effectively. Decentralization. Establish a decentralized network to reduce the reliance on the central authority, given a user more control over the data and the transactions done by them. Smart contracts. Utilize smart contracts to automate ride sharing agreements, payment processing, and dispute resolution, enhancing efficiency and reducing disputes. Identity verification. Using blockchain for uh, security identify verification allows user to trust the authenticity of their fellow carpoolers. Tokenization. Create a blockchain-based token system for payments, enabling easy cross-border transaction and uh, reducing current conversation SLS. So here few more objectives. User privacy. Prioritize user privacy by allowing them to choose the level of anonymity while ensuring the data protection. Rate and review systems. Implement a transparent and trust building rate and review system, enhancing the credibility of the drivers and passengers. Now, environmental impacts of this system. Promote carpooling to reduce carbon emission and congestion, contributing to a sustainable and eco-friendly transportation system. Scalability. Develop a scalable blockchain infrastructure to handle a growing user base effectively. User experience. Prioritize a user-friendly interface and seamless user experience to encourage adoption. Community building. Foster a sense of community among users through social features and incentive for active participation. Emergency response. Implement mechanism for emergency assistance such as SOS buttons or notification to trusted contacts to enhance the security of the passengers. Thank you.
Now let us discuss about the currently existing model. A user usually books for a cab using his mobile phone. The book request is sent to the Carpool API, which connects us to different servers like the Uber server or the Ola server, which allows us to request for a cab. This Ola or Uber server then connects to the Mix API, which takes our current location and the nearby cabs, thereby providing us with the fastest ride possible. Our proposed methods allows us to connect the riders and users directly through blockchain, thereby removing the necessity for third-party APIs like Uber or Ola. So the basic idea is that whenever a customer requests for a ride, the nearby drivers are given the current ride details and the ride fare is given to the user. The user may select whichever route he feels is most comfortable for him because it's a shared cab and other people will be using other routes. Once the ride details are confirmed, the driver is notified that a rider is ready for him. The driver picks up the rider, and then on the way, if any other riders wish to join, they can join in this path. We can also integrate payment methods like crypto to increase the security of our software. Building a carpool system using blockchain can provide benefits like transparency, security, and trust amongst users. Now let us discuss some of the technologies that we plan to use in our software. Obviously, blockchain technology. We plan to use blockchain technology for its decentralized and immutable ledger capabilities. Smart contracts will help us create contracts to automate rider sharing agreements, payment processing, and rule enforcement. Decentralized identities will allow us to keep hidden the identity of the rider as well as the driver, thereby increasing the privacy requirements of both users. Tokenization will allow us to create cryptocurrency within the app so that we can have a different currency within our carpooling ecosystem. An immutable data storage has to be constructed, which will be used to store essential information such as user profile, ride history, and reviews. The blockchain will ensure data integrity and prevent tampering. Conscious mechanisms such as proof of work, proof of stake, or consortium model for private blockchains. Privacy solutions such as zero knowledge proofs to protect sensitive information while ensuring compliance of data protection regulations need to be used. User interface. A deploy user-friendly mobile and web application for user driver to interact with the blockchain ecosystem of our carpooling platform.
To conclude this presentation, I would like to summarize our project in a few key points. The use of blockchain technology in carpooling applications has the potential to transform the way people share rides. By creating a decentralized digital ledger that securely and transparently records carpooling transactions, blockchain technology can help match riders with drivers, track payments, and ensure the safety of all parties involved without the inclusion of third-party apps. This technology can also increase efficiency, reduce costs, and improve the overall user experience of carpooling applications. However, there are still some challenges to overcome, such as adoption rates, scalability, and regulatory issues. Nonetheless, the development of blockchain-based carpooling applications represents an exciting area of innovation in the transportation industry with the potential to significantly reduce traffic congestion and carbon emissions. Further research and development in this area are needed to fully realize the potential blockchain technology in carpool applications. So now these are the few references which we have used in our project. Out of these, I would like to highlight two major references, that is the International Journal of Engineering Research and Technology and blockchain-based car sharing platform. This is the end of the presentation. Thank you.